So we go to 7C now. For 7C, the integral of lim x minus the root of x squared minus 1 dx. Okay, so here we go straight to our use substitution and see what happens. Let u be x minus the root of x squared minus 1. And then we solve the radical equation. So we bring the root of x squared minus 1 this side, and then have x minus u. Then you square both sides. So we're going to remain with x squared minus 1 is equal to x squared minus 2xu plus u squared, like that. Meaning, this can cancel. So now we're going to have 2xu equal to u squared plus 1. Like that, meaning that x is equal to u squared plus 1 over 2u. Like that. Okay? So when we get x in that way, we can even find dx now. So what should be our dx? So our dx is, or maybe I should write this as u over 2 plus 1 over 2u. Where I can factor out the half, maybe to avoid issues. I have like this. Then I differentiate with respect to u. So I'll have half, and then 1 minus 1 over u squared du. You see that? Then now we go back and substitute. So we have the integral of lim u. And our dx is this one. Half 1 minus 1 over u squared du. Then we expand it. This becomes half, excuse, half ln u du minus half integral of ln u over x squared, over u squared du. So we integrate now. Each piece here requires by part. What's the integral of ln u? You guys must know some of these integrals. So when integrating ln u du, you let's use what letters? Let w be equal to ln u, and then dz be equal to du. So we have dw equal to 1 over u, and then z equal to u. Then we substitute. So we're like doing the integral of w dz should be equal to wz minus the integral of z dw. This is the by parts. I've just changed the variables. So we have u ln u minus the integral of u over u du. There's a du here. Meaning we'll get u. So we'll get u ln u minus the integral of 1, which is u. So we would have found the first integral here. That's half u ln u minus u. Then we do the integral of ln u over u squared. Again, the same thing. I want to change the color. Okay. So again, the same thing. Let u be ln u. Let w be ln u, so that dw is 1 over u du. And then let z, this time around, be u to the minus 2, so that dz becomes, when you add the 1, becomes negative 1 over u, like that. And then you want to substitute, so have minus ln u over u plus the integral of u minus 2 du, which is minus ln u over u minus 1 over u as the integral of the second piece there, which will bring here, it's minus ln u over u minus 1 over u plus c. So I can trust you now. Where there is u, substitute u equal to x minus x squared minus 1 in the solution. I mean this one. Substitute here where there is u, put x minus root x squared minus 1 throughout, and that will be a solution. Okay. Any issues? We want to move to question 8. Okay. Tuasera. Question 8 is here. Write the reduction formula for each of the following and use it to evaluate the indicated integral. So here we can do 1. Unless otherwise, we can do 2 or 1. Which one?
The last two.
Okay. We'll start with C. Why is using the hard ones? That's 8. So 8C is the integral of x power n over the root of.
Sir, we can't get you.
Hello.
We can get you now.
Okay, x squared over x, xn over x squared plus 1 dx. So what's the integral of this? How do we approach it? So we can write this. We try to reduce the power of n. We write it like this, then multiply by x dx. And then we keep the denominator the way it is. Why are we doing that? We want to use a simple by parts to drive our formula. So we let u be equal to x n minus 1, and let dv be equal to x over the root of x squared plus 1 dx. So we have a du equal to n minus 1 x n minus 2. And our v, the integral of this u substitution. So you are letting your u again to be x squared plus 1. And then your du will be 2x dx. I think we did this type of integral, except we just had x squared plus 1 in the, not in the root. Okay, so after you work out your dx, your x dx turns out to be du over 2. And then you can substitute there. You have your integral as 1 over 2 du over root u, meaning you have this du. So you can now work out that integral. That way. So what will be the integral? It will be half. When you add the 1, it goes back to half, over half. So these cancel each other. So we're going to get the root of x squared plus 1 as our v. So we're saying if we put this in, now we're saying this guy is equal to uv, which is x n minus 1 x squared plus 1 minus n minus 1 x n minus 1 root x squared plus 1 dx. So again, we redo. We need to do the same thing here again. What about you now? If I can remove this part, I want to use it. Yeah. So to integrate this, we let u be the root of x squared plus 1 now, and dv be x n minus 1, I think. That should be the only way there. So that we get our du to be what? This is the same thing as x squared plus 1 power half. So it will be half x squared plus 1 power minus half 2x. And then our v will be xn over n. Yes. So we can work out this, the 2's can cancel, and we end up having x over the root of x squared plus 1. So we come back and substitute. So we have xn minus 1 root x squared plus 1 minus n minus 1, and then uv, that's xn x squared plus 1 over n minus v du. That's 1 over n integral of this x times the xn there becomes xn plus 1. Funny enough. Can I allow this? Let's see. So this can't be allowed again because it has become bigger than what we are looking. Ooh. This one can't work out because our n has become big. So maybe we take it back to this form. Oh yeah. There was no need of this, I think. There's no need of all this. You leave it here. Since the n has reduced. Except this should be x power 2. This one. This is n minus 2. Yeah, since n minus 2 here. Yeah. So since the n has reduced, in reduction, our main purpose is to reduce the n. So if the n has reduced, then I think that's enough to be called a reduction for me. So let's see if we can apply it on when n is 4. Can we apply to integrate x4 over this? So we're saying I4 is going to be x 4 minus 1, that's 3, which x squared plus 1 minus 3, x 4 minus 2 is that. Like that. Yeah, so we can move on. Because on this one, the fact that these guys, there's part 2 there, we can use trig substitution, even u substitution. Let's try u. If I let u to be x squared plus 1, then meaning that we're going to have x squared is equal to u minus 1. So that will be dx. 2x dx will be du. How can it be? It can look like this. U minus 1 as x squared, integral of u, then dx would be du over 2x. So that can be a bad integral again. Is it? Not necessarily bad, because then x can be root u minus 1. Okay, yeah. It can be a bad integral. So we can use other methods. We can use even trig substitution. Since we have x squared plus 1, we can let x be, since this is 1, so we'll have 1 tan theta. And then dx will be sec squared theta d theta. So we can substitute just this one. That's the integral of where there's x squared, we'll have tan squared theta. Then the root of tan squared theta plus 1. And then dx sec squared theta d theta. So this is sec squared theta inside, which is just sec theta. So we have tan squared theta sec theta sec squared theta d theta. And then you can do the multiplication if you want. Two options. No, not two options, only one. Because this is squared and this is power 3. So we are forced to change tan squared to the sec identity, which is the sec squared minus 1. So we have sec squared theta minus 1, and then sec 3 theta d theta. Then you can expand this to sec 5 theta minus sec 3 theta d theta. And then you integrate this using what? These are the powers of sec. So you use reduction for sec. Hope you know the reduction for sec. So I'll just give you the reduction for sec, then you guys can finish it. If this is sec n, you have 1 over n tan theta sec n minus 2 theta plus n minus 2 over n minus 1 I n minus 2. So this is your I n. This will be your integral first. So the only job you have is where is the first one, your n is 5. You substitute throughout, it will drop to 3. So whatever you do to the 3, this one just takes 1. Okay, you finish up this one, is it? It's quite long, so you have to enjoy a bit. We move on to, now D will be long again. We move on to D, and we go to 9. Hello. People are tired, eh? Okay, let's go to the next one. The next one is D, as agreed. The integral of dx over a squared plus x squared n plus 1 dx. Where we are told that a is a real number. So where is this coming from? In case you don't have the paper, this is coming from here. We are doing part D, 8D. So here, we use by parts. Of course, we normally call our integral IM. So let u be equal to 1 over a squared plus x squared n plus 1. And then differentiate it to get u. So this can be written as a squared plus x squared minus n plus 1. So when we differentiate, it will be this a squared plus x squared. There we subtract the 1, so it will be n plus 1 minus 1. And then we multiply by the derivative of the inside, which is 2x. And then our dv becomes dx, so that our v becomes x. And so we write our im to be uv, that is x, over a squared plus x squared n plus 1 minus minus, so it becomes plus 2 over n plus 1 left outside and then integral of x over a squared plus x squared. Let's see what the power became. So when we worked out the power there, it was minus n minus 1 minus 1, which is minus n minus 2, which is n plus 2 dx. Like that. So after this combination now, we're able to integrate the other piece that side. We can do any magic that we feel like doing. So this was actually in plus 1. I don't want it to become too long, so I'm trying to see what best can be done. Okay, let's try this. To integrate this part, you let your u be the denominator, a squared plus x squared. Since our du can be 2x dx, where we can have x dx being du over 2. Can we squeeze this? That can be 1 over 2. Quickly have du, have u minus n plus 2 du, so that we get the integral of u. When we add the 1, it will be minus n plus 2 plus 1 over minus n minus 2 plus 1, which will be half. Okay, so the numerator, so now I can bring it back. This will be x over a squared plus x squared, n plus 1 plus 2 over n plus 1. And then this is half this one. And then that will be 1 over that would be minus n minus 1. So which would be u minus n minus 1. This is like n plus 1. Yeah. And then u to the power the same. What is u? U is a so this, okay, let's try. This is a squared plus x squared n plus 1. The problem is that this can diminish the integral. Yeah, this can diminish the integral, so it can be reduction. Yeah, it can diminish the integral, so we don't want to diminish it. So it means that we need to find a smooth way of doing it. So let's get back to the integral question. Otherwise, it was diminishing it, so it can be reduction. Yeah. Okay, so how do we get back to reduction? Let's use some magic. So we'll have 2 over n plus 1 integral of, instead of having x, here, what did you have? Oh, So we have this 2x and that x. So it was x squared. Oh yeah, I get. So we could not diminish it. So now let's try to do a bit of some magic. In the numerator there, let's try to make something that is similar to what we have in the denominator. By adding, so we have x squared, let's add a squared and then subtract it. I haven't changed anything there. So that this guy is like this. You know, when you add and subtract something, nothing has changed, is it? So that we can write this as this guy plus 2 over n plus 1 was come back. So okay. So I want to write this as x squared plus a squared over x squared plus a squared n plus 2 and then minus 2a squared n plus 1 integral dx over x squared plus a squared n plus 2, like this. So this is just a smooth way of trying to reduce my integral. So this guy is in equal to this n plus 1. And then if I want here, I have this guy. So this will reduce this by 1. So it's going to be 2 over n plus 1. This thing will be cutting in minute from now. So it will be the integral of n. Since it will be n plus 1, which is what we had here as our in plus 1. So it will be in, and then minus 2a squared over n plus 1 the other one remains the same, n plus 1. Yeah, so this is plus 1. And then you put the like terms together. So you move this to the left and then remain the in on the right, which has reduced from n plus 1 to n. Unfortunately, this meeting will cut within seconds. So maybe we can rejoin. If you're not tired, rejoin.